So we're gonna solve circuit exercise 3A using Kirchoff's laws for this, and I'm going to close this. I don't want to save changes, and I'm going to open up a little thing that has matrices on it, and I'll put the matrix up there, and then I'll also show you how to do it on your calculator if you've forgotten. But this is going to involve matrices. So the first thing to do is, I suppose I should draw this up here. And the method that we're going to use is simply going to find the currents through all these resistors. That's what it solves for. And it's up to you to use those currents to find the voltages. But if you know the currents through all the resistors, isn't it easy to find the voltages? I'm thinking it is, right? Okay, so this is 13 ohms, and 7 ohms, and 11 ohms, and 3 ohms, and 5 ohms. And do I have all the numbers right? I think so. Okay. Now, the first step for solving these problems this way is to trace the currents, right? Label the currents. And I'm going to call this current that flows here and here. It's the same current, isn't it? Right? Okay. I'm going to call that current I1. Now notice it's a current and not a man, because no man is an I1. Some laughter. There was some laughter there. Okay. Okay. Now the second current, I'm going to call this one I2, and I'm going to call this current I3. And that probably surprised you, because you weren't expecting I3 after I'd named the first ones I1 and I2, I imagine, right? That's, on the face of it, somewhat surprising, right? Okay. Now, the first rule is the simplest rule, and this is called the junction rule. And the junction rule says that for every junction, there's a junction right there, the currents flowing in equal the currents flowing out. This is just conservation of charge. So in this case, what we would say is that I1 equals I2 plus I3. Yes? That's because I1 splits up and makes these currents, and then it flows back together and it becomes I1 again. It's like a river, and the water doesn't soak into the ground. Okay? Kind of a thing. Does that make sense? Yes, no? Yes. Okay. So that's the junction rule. And in this case, we only have one junction rule that we do, and this is sort of the dodgy thing. Sometimes there's a couple junction rules we need to do. So if there's another unique junction, then you need to make another rule for it. But this one has only one junction. I could say that I2 plus I3 equals I1, but that wouldn't be a unique formula, right? And we're going to set up a system of equations, and if one of the formulas is the same as the other one, it doesn't work, does it? Yeah, it's like you get this, like, you try to solve it, it's like 10 equals 10. Oh, I bet it does, right? Okay. Now, the next rule is the loop rule, and the loop rule states that if we run a cross-country race, and the race is a loop, the net change in elevation in that race from the beginning to end of the race is 0. Okay, so going through a battery this way is going uphill, and going downstream through resistors is going downhill. That's a voltage drop. Okay, and so this rule simply states that the sum of the voltage increases and the voltage drops is 0 for a complete loop, right? So as I go through here, my first loop that I'm going to do is this. Okay? I'm going to start here. I'm going to go here, 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 and back. Okay? For that loop, what I'm going to do is I'm actually going to go on that loop. The first thing I do is I go up 17, right? Then I go down 3I1. Then I go down 18I2. I added those together. It's kind of cheeky, isn't it? Technically, I'm supposed to say 7I2 plus or minus 11I2, right? Negative 7I2 minus 11I2, but I'm putting them all together. Is that okay? Yeah, so minus 18I2 and then minus 5I1. And there's another equation, yeah? Where am I getting this? What is R times I? Isn't that voltage? I'm just doing IR. These are the IR drops, right? Okay. And I'm writing them RI instead of IR because that's the way we write equations. Okay. We always put the number and then the variable, right? Okay. So that's my first equation. Let's double check this. Say it again. Negative 9. What's negative 9? I think this is negative 8, isn't it? This guy, are you putting those two together? Oh, I see, but these have letters, these are variables on them, so we can't combine them yet, right? Yeah. I can do this, so I can rewrite this formula plus 17 minus 8I1 minus 18I2 minus 0I3 equals 0. I can write it that way, can't I? And you're like, why would you write it that way? Well, just hold on, right? Okay. Isn't this the same thing, same equation? Yeah, okay. So that's loop equation number 1, right? So going through the battery this way is a positive change in voltage. If I went this way, it would be negative, right? If I went upstream through a resistor, the pressure would increase. If you go downstream, it decreases, right? So going this way is like going downhill. And then we need one more loop, so I'm going to start in the same location. And you have to visit all parts of the circuit with this, right? So it's like, there's my final one, is I'm going to go retrace my path here, but then I'm going to go this way. Because I heard it's really pretty out here. You know, I want to visit that part of the circuit, right? I want to see the whole world, you know? And then this one looks like this. The first thing I do is I go up 17 from negative to positive, right? Down 3I1, and then I'm over here down 13I3, right? Then down 5I1, and then have I done the whole thing? 3, 13, 5, and I'm back, right? So that equals 0. Are there questions about these equations so far? Because it's not going to get more clear. What I'm going to do now is just do math, right? Obviously, we have 3 equations, 3 unknowns. It's solvable. We're going to use matrices, okay? Very little pain involved, right? So let me write the formulas again. I'm going to rewrite this guy this way. I1 minus I2 minus I3 equals 0. Isn't that correct? Why am I writing it that way? Don't I have to line everything up for a matrix? Yeah. Okay. I'm going to put all the things that are I1 here, then I2 terms here, I3 terms here. All the other things that are not I1, I2, or I3 get put on this other side, right? Okay. Then let's take this guy here. I'm going to write this guy this way. 8I1 minus 18I2 minus 0I3 equals 17. Can't I do that? Except these guys are plus, aren't they? Aren't they? Is that right? Yeah, because if I just take these guys and I put this guy on the other side, it's negative, make everything positive. We've got it. It's very bad if we get this wrong. Do we get it right? I think so. And then I'm going to rewrite this guy as 8I1 plus 0I2 plus 13I3